Hello, good morning. In this class, we try to draw the bending moment and shear force diagram for overhanging beam. Let me draw a overhanging beam. Overhanging means two supports and one side is free, there is no support. Also, it may be left side or right side. Let me question. Through the question, we try to understand how to draw the bending moment diagram and shear force diagram, how to draw the bending moment and shear force diagram for overhang beam. Let me try to understand through a problem, a simple problem at its most important problem. Through the problem, we try to understand the bending moment and shear force diagram for overhang beam. So the overhang beam, the length of the support to support length is say 8 meter, and the overhang portion is, let me consider, 2 meter length. Let me draw clearly. Overhang beam, support to support length is consider 8 meter, and overhang portion, length of the overhang portion is say considered 2 meter, and a uniform distributed load up to center of the support, that is up to 4 meter distance, this uniform distributed load 4 meter, and a point load at the overhang free end point is say 20 kilonewton, and the uniform distributed load considered as 30 kilonewton per meter. Let me draw the shear force, and now try to draw the shear force and bending moment diagram for this beam. This is a overhang beam. We try to understand through the problem, directly through the problem, the overhang beam. Very important, overhanging beam. The question can ask in examination from overhang beam, draw the shear force and bending moment diagram. Let me consider a point A, the support point A and support point B, and this is point, let me point C, and this point is D. First we have to find out the reaction of those support A and B. Reaction at support point A, which is RA, and reaction at support B, which is RB. We can consider moment about point A is 0. Always moment at support point is 0, but in the overhang portion the moment at the point B can never be 0. It has some moment. So taking moment about point A is 0. All the moment of all the force at point A is equals to 0. Summation of moment A is 0. Now find out the moment about point A. Now let me find out the moment about point A. the RA reaction RB, the moment at point is anti-clockwise, that is negative RA into RB into perpendicular distance. Total perpendicular distance is 8 meter. And for this load, 20 kilonewton load is totally, for remove this reaction and this 20 kilonewton load, the moment at point A is clockwise moment, that is positive. So 20 into total perpendicular distance is 8 plus 2, that is 10 meter, plus for this 30 kilonewton uniform distributed load, the moment at point A will be 30 into perpendicular uniform distributed load up to 4 meter length into perpendicular distance is 4 by 2, that is 2. This all are the moment at point A, which is equals to 0. Now find out the reaction at point B and reaction at point A. Now reaction at point B, this is the 8 RB is equals to 10 into 20, 200 plus 8 into 3, 24. 240, which is equals to 440. So RB is equals to 440 divided by 8, which is equals to what? 440 divided by 8. This is 55 kilonewton. The reaction at point B is equals to 55 kilonewton. Let me write the RB reaction at point B equals to 55 kilonewton. Now find out the reaction at point A. Reaction at point A, which is RA plus RB, is equals to the total load are applied on the beam, which is equal to 30 kilonewton uniform distributed load up to 4 meter length, 30 into 4 plus what? Plus 20 kilonewton. 20. This 30 into 4, 120. 120 plus 20, that means 140 kilonewton. So RA is equals to 140 minus 55, which is equals to 140 minus 55, which is equals to 85 kilonewton. This our reaction at point A is equals to RA equals to 85 kilonewton. 85 kilonewton. Now find out the shear force and bending moment diagram. Draw the shear force and bending moment diagram. First, we have to find out the shear force, then draw the shear force diagram. Let me draw the beam. This is 85 Newton reaction. This reaction force 55 kilonewton, kilonewton, and here point load is 20 kilonewton and uniform distributed load up to this 30 kilonewton. This is point A, point B, point C, and this is point D. Now find out the shear force of each point. Shear force at point A, is equals to reaction force at point A, that is 85 kilonewton, Now shear force at point D. Shear force at point D. Shear force at point B. Shear force at point A, 85 minus 30 kilonewton upward downward direction force, 30 into up to 4 meter length. This is the 4 meter length, 4 meter, and this is also 4 meter, and this is 2 meter. Total distance is 8 meter. 4 by 4, 4 is divided by 4, 4 plus 4. So 30 into 4 up to 4 meter length uniform distributed load, that is equals to what? 85. This is 120. 85 minus 120, which is equals to 55 Newton minus kilonewton, 55 kilonewton minus. Now shear force at point B equals to reaction force at point B always, right? The reaction force at point B. That is minus sorry 55 not, this is 85 minus 120, 85 minus 120, which is equals to minus 35. I'm sorry, really sorry, minus 35 kilonewton, minus 35 kilonewton. Now shear force at point B is equals to what? Shear force at point B is reaction force. That means reaction force also we have to shear force at point D is equals to, from left and right portion. From the left portion is shear force at point B, from the left portion is shear force at point D. Just to left is shear force at point D, which is equals to minus 35 kilonewton, and shear force at point B just to right will be shear force at point D, shear force at point D plus upward force is 55, upward force is 55, upward force is 55 kilonewton. Shear force at point D is equal to minus 35 plus 55 equals to 20. Shear force at point C also, shear force at point C also, load at point C, that is 20 kilonewton, 20 kilonewton. Once more, let me discuss once more. The shear force at point A is equal to reaction force, that is 85. Shear force at point D equals to 85, reaction force 85 minus 30 kilonewton uniform distributed load, which is acting downward up to 4 meter length. So 30 into 4, that is 85 minus 30 into 4, this is 120, that is minus 35 kilonewton. Shear force at point D is 35 kilonewton. Now shear force at point B just to left, this is point, like a point reaction force, point load, just to one will get, we will get the left side shear force and other one will get right side shear force, and this left side shear force will be consider the shear force at point D. The shear force at point D is equals to minus 35 kilonewton, and shear force just to right will be reaction force upward direction, means positive shear force, positive, that is minus 35, reaction force shear force at point D minus this load minus 35 plus 55, that is 20 kilonewton. Now shear force at point C is equals to, which is load on the point C, that is 20 kilonewton. Now draw the shear force diagram. Shear force at point A is 85 kilonewton. Shear force at point D is minus 35, which is linear from A to D. So 35, and shear force at point B just to left is, this is 85, this is 35 minus, and this is also 35, and shear force at point B is just to right is positive, that means up. So shear force is 35, this is 20, up 20, and shear force at point free end is 20. This is a positive shear force. A positive shear force. This is a negative shear force. This is also positive shear force. This shear force diagram is 20. Now find out the bending moment and draw the bending moment diagram. Let me draw again the beam. 85 kilonewton. This is 55 kilonewton reaction force. Point load 20 kilonewton. And up to point C, uniform distributed load. Uniform distributed load what? 30 kilonewton. This is 4 meter. Total length is 8 meter, support to support 8 meter, and up to overhang portion is 2 meter. Overhang portion is 2 meter. This point A, point B, point C, point D. Now bending moment at point A is equals to 0 at support. Now bending moment at point D is equals to what? Reaction force at point A 85 into perpendicular distance 4 minus 30 kilonewton uniform distributed load into up to 4 meter length into perpendicular distance is 4 by 2. 85 into 4, 85 into 4 minus 30 into 4 into 4 by 2, which is equals to 100 kilonewton meter. Bending moment, now find out the bending moment at point B. Bending moment at point B is equals to what? Bending moment at point B is equals to 85 kilonewton load up to into perpendicular distance, total perpendicular distance at point, we have to find out the bending moment at point B. Perpendicular distance is 8 into 8 minus uniform distributed load up to 4 meter length 30 into 4 meter length, and perpendicular distance 4 by 2 from center to B, 4 by 2 plus 8 minus 4, that means 4. 4 by 2 plus 4. The bending moment at point B, moment at point B. Let me calculate 85 into 8 minus 30 into 4 into 4 by 2 plus 4, that means 6 into 6, which is equals to minus 40 kilonewton meter, minus 40 kilonewton meter. Now bending moment at free end, bending moment at free end always 0. Yes, is that clear? Bending moment at point C is 0. Bending moment at free end there is no bending moment. The bending moment at free end is 0. Let me calculate a bending moment at free end. 85 into total perpendicular distance, 8 plus 2 plus minus 30 kilonewton uniform distributed load, 30 into perpendicular distance into up to load 4 meter, 30 kilonewton up to 4 meter into perpendicular distance 4 by 2 plus 4 plus 2 plus 50 kilonewton upward force into this is 55 into perpendicular distance 2. Moment about point C for 50 kilonewton is upward direction. That means positive clockwise moment, positive. For this load it is also clockwise moment, positive. 85 for reaction force 55 clockwise. This is 55 into 2. Now calculate it. It will be 0 definitely. 85 into 10 minus 30 into 4 into 2 plus 4 6 8 2 4 into 8, this is, and plus 55 into 2 which is equals to 0. This is the bending moment of this point at point C is 0. Definitely bending moment at free end will be 0. Now draw the bending moment diagram, and after draw the bending moment diagram we try to more concept of one interesting point, that is point of contraflexure. Bending moment at point A is equals to 0, moment at point A equals to 0, moment at point D is equals to 100 kilonewton, which is parabola. This is D, this is point B, reaction support, parabola, 100 kilonewton parabola, and moment at point B is equals to minus 40 kilonewton, minus 40 kilonewton here. This is the linear, this portion is linear, and also this portion is bending moment at point C is 0, linear. Moment at point C equals to 0. This is a moment at point B equals to minus 40 kilonewton meter. Moment at point D equals to 100 kilonewton meter. This is a point B, D, and this is point B, this is point C. Now find out the zero moment from one support. This point is known as point of contraflexure. Point of contraflexure. Point of contraflexure. Let me consider here the bending moment is 0. Say this is the bending moment is 0 at this point. Say let me consider this is the XX section. Here the bending moment is 0. Moment is 0. Moment is 0. Let me consider this distance is equals, this distance is, let me consider this distance is x. This distance is x. Also we can also consider from here, also we can consider the distance x. Let me consider this distance x. So this distance equals to 8 minus x. 8 minus x. Now find out the value of x from this support. This is the point of counterflexure distance, point of counterflexure distance. Now at that point, at this point, the bending, what will be the bending moment at this point? At this point bending moment is 0. Here the bending moment is 0. Now bending moment at xx section, bending moment at section xx, at section xx is, section xx is 0, xx is 0. Now find out the bending moment at point xx point, that is 85. This is 85 into perpendicular distance is 8 minus x. 85 into perpendicular distance is 8 minus x. 85 into perpendicular distance is 8 minus x. Positive minus 30 kilonewton load, minus 30 kilonewton into up to 4 meter distance length into perpendicular distance. Into perpendicular distance what? Perpendicular distance is 8 minus x minus 4 by 2. From here to this distance is, this distance is what? This distance is 2 meter. 4 by 2, 2 meter. So from here to here the distance will be 8 minus x minus 2 into 8 minus x minus 2. That means 6 minus x. This moment is 0 at point xx point. At this section the moment is 0. Then we can find out the, now we can find out the value of x. Now find out the value of x. This is 85 into 8. 85 into 8. Calculate it. 85 into 8, which is equals to 680 minus 85x minus 120. 120 into 8. 120 into 8, which is equals to 960. Sorry, 120 into 6. 120 into 6. 120 into 6. 720. 720. This is 720 minus 120 minus minus plus 120x. This is 85. Sorry, 85. 120x equals to 0. 120 minus 85. 120 minus 85. This is equals to 35. That means 35x is equals to 720 minus 680. This is 45 equals to 40. So the value of the x will be, x equals to 40 divided by 35. 40 divided by 35. Let me write here. The x equals to 40 divided by 35. 40 divided by 35. This is equals to 1.43 meter approximately. So point of distance, point of counterflexure from point B, from point B is equals to, from point B is equals to, point of counterflexure from point B equals to 1.43 meter. 1.43 meter. This is the point of counterflexure. You can write down the definition of point of counterflexure. Point of counterflexure. Write down the point. Write down point of counterflexure. Point of counterflexure is defined as, write down. Point of counterflexure is defined as as where the bending moment its change in sign, where the bending moment is change in sign. That means the bending moment sign of the bending moment from positive to change positive to what? Positive to negative. Positive to negative. Sorry, this is a negative. I am really sorry. This is negative. Negative bending moment. Directly change from positive to negative bending moment. From positive bending moment to negative bending moment. This is called point of counterflexure. I hope you understand. Thank you so much.